Today, we're jumping into a real-life scientific detective story. It's a mystery that kicked off with this really strange, really sudden change in our planet's atmosphere. A change that, honestly, scientists are still scrambling to figure out.
So what's at the heart of it all? The big question is, what strange force is heating up our planet? And, the answer isn't as simple as you might think. It involves a gas that's been hiding a massive secret right under our noses.
Okay, so let's rewind. Our story really kicks off in 2006. This was the year that scientists, the folks who keep a constant eye on our atmosphere, noticed something was deeply wrong. A crucial signal from the planet had suddenly gone haywire, and nobody knew exactly why.
And what they saw was this sudden, strange spike. A totally puzzling anomaly in the chemical makeup of our air that really marks the beginning of this whole mystery. The culprit? Methane. See, for years, methane levels in the atmosphere were pretty stable. But then, in 2006, they just shot up, completely out of the blue, and they haven't stopped rising since. Now, at first, scientists thought they had a pretty simple explanation, but as we're about to find out, the simple answer was nowhere near the whole story.
So, let's back up a second. What is methane anyway? Well, it's a super potent greenhouse gas. The easiest way to think about it is like a blanket for our planet. It traps heat, keeps things warm. Simple enough, right? But not all blankets are created equal. Right, so we talk a lot about carbon dioxide, CO2. You can think of that as a warm blanket. But methane is a whole different beast. It's like a much, much thicker, heavier, industrial strength blanket. To put it in perspective, over a 20-year period, it's more than 80 times more powerful at trapping heat than CO2. And that is why the sudden spike has everyone so worried. So who was the first suspect? Well, the obvious one was us, right? Human industry, farming, all our pollution. It just made perfect sense. But here's where the mystery really deepens. When scientists actually dug into the numbers, they realized that human activity alone, it just couldn't account for how massive this new surge was. To get to the bottom of this, scientists had to look way, way back in time. They turned to one of the greatest historical records on the entire planet, ancient ice. Because it turns out the Earth keeps its own diary, and it's all frozen in time. And how do they read this frozen diary? With something pretty incredible called an ice core. These things are basically time machines. They're drilled from deep inside the ice sheets in places like Antarctica, and they hold these tiny trapped air bubbles, perfect little snapshots of what the atmosphere was like hundreds of thousands of years ago. The process itself is, it's pretty straightforward, but the results are amazing. They drill down, sometimes for miles, to pull up these long cylinders of ice. Then, in the lab, they very carefully release that ancient air from the bubbles and analyze it. And just like that, they have a perfect year-by-year record of greenhouse gases from the distant past. So when they looked at this super long-term methane record, a stunning pattern just jumped out at them. It turns out, roughly every 100,000 years, like clockwork, the planet's atmosphere gets a massive spike in methane. And every single time that happens, it lines up perfectly with the end of an ice age and the beginning of a warm period. It's like Earth's natural climate pulse. But here's the kicker. This is the whole puzzle. That last huge natural methane spike, it happened just 12,000 years ago when the last ice age ended. According to the planet's own schedule, we shouldn't be due for another one for, about 90,000 years. So, what on earth is going on right now? And that 100,000-year cycle, it's not random at all. It's actually governed by Earth's long, slow dance with the sun, a kind of cosmic clockwork that has been setting our climate's rhythm for eons. This cosmic clockwork has a name, the Milankovitch cycles. Basically, they're three really long-term changes in Earth's orbit and its rotation that, when they line up just right, trigger these natural warming and cooling periods. Okay, so there are three main parts to this. First, you've got eccentricity. That's just the shape of Earth's orbit changing from more circular to more oval, and that happens over a 100,000-year cycle. Then there's axial tilt. The angle of Earth's axis shifts, which changes how intense our seasons are. And finally, precession. You can think of that as the slow wobble of Earth's axis, kind of like a spinning top. When these three cycles align in just the right way, they gently warm the poles, which starts melting ice, which then releases methane, and that feedback loop is what ends an ice age.
Okay, but we already established that the planet's natural clock says it's not time for a spike. So that forced scientists to come back to the present day and start hunting for the modern-day suspects. Where exactly is all this new methane coming from? And to do this, they're using some seriously cool technology. We're talking satellites that can fire specialized lasers down at the Earth. Now, this laser light has a very specific wavelength that gets absorbed by methane. So, if the laser beam doesn't bounce back up to the satellite, bingo, they know they've found a plume of methane. Using this method, they've literally created a global map of methane hotspots. And it has revealed some absolutely staggering industrial leaks. For example, in Iran, a single landfill was found to be spewing out methane equal to the weight of 180 jumbo jets every single year. Or look at Turkmenistan. A bunch of oil and gas fields are leaking about 40,000 kilograms of methane every hour. That's insane. It's like the emissions of hundreds of thousands of cars, but every single hour. So yeah, these human-caused sources are a huge problem, no doubt about it. But they still aren't the whole story. As scientists started adding everything up, they realized that an even bigger chunk of this methane had to be coming from somewhere else, from a massive natural source that's, well, becoming dangerously unstable.
And this is it, the #1 suspect behind that 2006 spike, the thawing of Arctic permafrost. We're talking about land that has been frozen solid for thousands upon thousands of years, trapping unbelievable amounts of old organic material. As our world warms up, that ground is thawing, and as it thaws, all that ancient stuff starts to decompose, releasing these vast quantities of methane straight into the atmosphere.
All right, so let's put all the pieces of this puzzle together. We've got a warming planet, which is causing permafrost to thaw, which then releases more methane, which in turn causes even more warming. You see the cycle. But the really scary part, it's the timing of it all. And this, right here, is the most important part of the whole story. In the past, these huge methane burps had a job to do. They were the planet's heater, pulling it out of a deep freeze, out of an ice age. But this is the first time in hundreds of thousands of years, that a spike this big is happening during an already warm period. The planet doesn't need a heater right now. And that's what has scientists so worried. They can look back through all that ancient ice for hundreds of thousands of years, and there is simply no precedent for what's happening now. We're essentially piling a massive warming event on top of an already warm climate. We're completely off the map.
Which brings us to the final, really unsettling question. If this huge methane release is basically a natural feedback to the warming we've already caused, have we accidentally pushed the Earth into a new climate phase? A phase that might be beyond our control to stop? The mystery that started back in 2006, well, it's led us to a pretty profound question about what comes next.